Hi, welcome to a new video dedicated to a new project from AOMWAY. This is their first HD FPV system. So it means that this system is able to transmit the video signal in 720p and even in 1080p resolution. So how it's working is based on numeric modulation. Based on OFDM technologies, specialized OFDM technologies, able to broadcast the signal with a minimum of latency. As you may know, the big problem with whole numerical modulation, like you can meet for HD TV, is the latency. So you need a system able to reduce the latency as strict minimum. So let's discover a little bit this bundle. First, here is the basic packaging. I received mine directly from AOMWAY with this two letterbox. That's also, maybe it's a pre-release version. Anyway, here are all the elements. This is a transmitter, including a fan on top, and on each of them you have the list of the 10 supported frequency. Be aware, the system is using the same frequency band than the DVB-T TV system. So it means that for most of country, this system is probably not loud, okay, because it's exactly working on the same band around 500 megahertz. Okay, so be aware, and I will try to make a test if there will be some interferences between an existing TV DVB-T channels with this system. Okay, so here is the transmitter. As I said, with the fan installed on top, you have a ACME connector, okay, and two LEDs, one for the power connection and one the blue for the link, if the link is established between the receiver. On the bottom side, you have a full HDMI connector, okay, 4-position deep switch to select one of your 10 frequency, and a unique DC power plug. You can power it from a 2S up to 3S. Not sure 4S is supported. I don't receive any instruction manual. So it's this system is boxed into a metallic casing, pretty heavy, okay, probably to cool more efficiently the system and to protect from the emitted RF. Okay, so it's a shielding casing as well. So let's give you an indication about the weight from the transmitter. So standalone without power plug antenna, this system is already weighing 103.1 gram. So if you had, here is a 2 power cable already soldered, a JST connector, but it came without. But if you had the power connector, of course you can reduce the length, but it's already 124 gram. And with the antenna you have already 144.6 gram, and you have to add the HDMI connector to your HD camera. Okay, so basically if you don't select any ultra lightweight HDMI connector, you have to add 20-30 extra grams more. You have to add also the HD camera, so you can get that all the system out of the box is much more heavy and exceeding 240 grams. It's a lot. Of course, there is some trick to save some weight. So let's discover a little bit the receiver. No fan here, but still the same selector, more installed on the up position, upper face. You have exactly the list of frequency. As you can see, the first channel is started at 500 megahertz, while the last is 572 megahertz. You have to know that this band, the frequency shift from 2 megahertz from existing DVB-T channels. Okay, so you have to know that each channel have 8 megahertz of bandwidth, okay, but the central frequency is shift from only 2 megahertz from an existing TV1. Okay, so I don't know if there will be some interferences. You have to know that this system is using QRM modulation plus OFDM techniques, and the main advantage of OFDM is to be able to fight interferences coming from adjacent signal. So I hope it will be efficient enough to reject even only separated by 2 MHz, it will be able to reject the other TV channel, or more, I hope the system won't interfere with any existing DVB channels. That will be the main problem, of course. So on the bottom side you will find the same HDMI and the same LEDs and the DC power. So as I said, let's give a weight of the receiver. It's lighter, probably because you have the absence of the fan, etc. And we will see inside there is a lot of much more element on the transmitter part. So this basic antenna, and as you can notice, is not an antenna adapted for the 500 MHz. It's nothing else than the 5.8 GHz one. So it means that in practice the antenna inside is much shorter than the what you should have. So the more important, I would say, that the impedance matching is done at least with the antenna with this transmitter system. Okay, that's I think it's a 50 ohm or 75 ohm, I know, but it's more important. Okay, if the antenna lengths are not the right one, and it's clear that it will be much shorter, 5.8 GHz divided by compared to 500 MHz, you have should be 10 times more longer. Okay, we should have something around 10 centimeters, and it's not the case, but it's causing a big problem. If the impedance are matching, I think it won't create any problem, but for sure you won't transmit as far you can do. Okay, so if you want to replace this antenna with more antenna with the correct length, it will be much more efficient. Okay, so I talked with an AOMWAY engineer guy, said no problem, you can use this antenna, but of course now you are warned, they could be more efficient. Okay, so that's another warning I want to indicate to you. So basic power cord, they can be reduced. Okay, the positive is inside, the ground is outside. As I say, you can power from a 2S, okay, or 3S, no problem. And let's now have a look a little bit inside. I will open the casing and show you the electronics. Okay, here is the internal part. So the transmitter, I detach this connector. This is the main power. Okay, but you can find all the electronics, and you have two modules, okay, protected by the metallic casing here. So, and linked with this antenna, this one got a micro FL connector, and this is a power cable to be connected here. But as you can see, you have some remaining UART port here, and USB remaining potentially. So maybe they remove this connector, but it will be possible probably to flash a new firmware if required. You have another connector here, but the electronic is pretty clean. Okay, the fan system, I will show you the photos in the full reviews, but you have the main processor chip, and I don't know what kind of RF module is it. Probably here, this is the main power one, okay, to transmit the power. I will measure the power, emitted power in few instants anyway, and probably here more for the OFDM and QAM modulation. I'm not completely sure. Sounds pretty clean, and this metallic casing is playing the role to cool all the general system and also to protect RF shielding. So for the receiver, I can already give the information of the one of the part of the metallic casing, so we can guess the general weight. So 26 grams. So if we multiply by 2, we will be around 52.6 or 8, sorry, gram approximately. So 52, almost 53 grams versus 88. So we can see that we can get that the electronics is around 30 grams. Okay, here we have a little bit more electronics, so we should be around, all the video transmitter electronics should scale around 35-40 grams. Okay, so the main open question is why they use so heavy metallic casing, because the total weight will be so important, and how to carry this system into a flying machine, at least a small one, it would be almost impossible. So a minimum of 350 millimeters quadcopter. Okay, it means that we have to save some weight. So one way will be to, for example, to transfer the electronics into a plastic casing or 3D printed. But what about the RF shielding? Maybe by covering and some AMI tape around this 3D printed will shield everything. Okay, but I think around 50 grams could be saved, or 40 grams could be saved from this metallic casing. So for the version V1, it's a problem. I spoke with the AOMWAY guys. They say they are working maybe on the V2 to reduce the weight. They are aware about that. Okay, so let's see the receiver, and you can see no fan, but you have a sink here to cool the system. Okay, but more passive. No power is emitted here. Okay, so now I want to measure the emitted power and start to make some first demonstration of the system, and of course give you the probably what you are expecting. What is the latency of such system? Okay, so I connect my immersion ARC module. So I'm not sure it's well adapted to such kind of modulation. Anyway, I try to find one frequency the closest to the 500 MHz, so for the lower bound of the 572 MHz, and I found that the closest is 430 MHz because the upper one is 868 and the lower was 72 MHz. So I will select this 433 MHz, install the attenuator, and let's power the system. And I repeat, I'm not completely sure that the measure will be accurate because is not a full system. Okay, it's not really associated with such kind of system. Okay, and actually I've got close to 500 milliwatts emitted. Okay, so not so bad. So it's a lot. Okay, and you can see sometime is decreasing. Okay, because probably I don't have the contact with the receiver, so it's lower than the emission. Now is a return to 583. Okay, close to 500 milliwatts. So it's a lot. It's a lot. As you can see, I'm not sure. Also, the emitted power is compatible with the load powered in this band. Okay, so maybe another drawback too. Okay, now let's start to show you the efficiency of the system. What I will do first is to give you the latency of my HD cam, okay, because this one on the HDMI output is unfortunately producing some latency, and to measure the latency of the system we have to first measure this one before without FPV system. Okay, so I connected directly my GoPro clone. This is a black view or Aero 2 basic one. So I will power this AOMWAY FPV monitor, and this one got an HDMI input. That's great. So this monitor take a couple of seconds to boot. Okay, around 10 seconds, and I would select the HDMI. Okay, I will power on the camera in the same way. Okay, and here I can select. Okay, I got HDMI input pre-selected, and as you can see, it's not a problem. So let's measure a little bit the latency, but we can get that there is one. So I will measure here on the chronometer. Okay, sorry. Okay, so I will start here, and we'll be able to measure here. And let's have a look to the latency, and what I can see, I will take a pictures between both. Okay, yeah, we can see it's around so now what we do is to power the system and to observe the quality of the FPV transmission, of the HD transmission, and measure the latency. Okay, so let's do the test. I will power the FPV monitors, power the receiver. Okay, section, you have the LEDs appearing. I will pour now the camera, and then the transmitter. Okay, so you can hear the fan spinning, and after a couple of seconds you will see the signal. So as I said previously, after a couple of seconds the image will freeze and reappearing. You have the no signal, okay, and the signal will reappearing. Okay, so now it's okay, you can see. And good news, the latency don't seems to be really much more important versus the original one brought by the camera, but the FPV transmission is not super great. Look for oblique. Hope you're able to see. For oblique, you can see the artifact. Look around the antenna stick. You can see the pixelization of the compression, okay, around the stick antenna. And for unicolor, you can get also the pixelization, the white color on the background. You can see close to the tablet. Okay, so now let's measure a little bit more the true latency. Okay, and I will okay, reinitialize everything and start the chronometers. Okay, hope you will be able to see. Okay, white. So make a pause to measure, but it seems not bad at all. So you have something around so it seems that the extra latency is really small, at least for proximity distance. That's great. So it seems to be not exceeding something around 50 milliseconds. Okay, that's great. Yeah, so definitively if you have a camera with very low latency, this system in terms of latency is very efficient. Okay, the secret probably it's downscaling every source to 720p. Okay, and use a huge amount of compression level in the QAM modulation. Okay, so to reduce the latency, there is no secret. Okay, so I will now make a small tour around to show you the FPV distance and to show you some real data. So I don't have any HMI recorder. Okay, so I will film these FPV monitors and you will be able to guess the quality of the system.